Hello everybody, it's Mr. Moore again. Today, we are going to be talking about multiplying and dividing fractions. Right now on screen, you're looking at the Texas Go Math Grade 6 book. This is not specifically associated with this particular curriculum, being that a 6th grade pre-AP student would be studying 7th grade material. But this is sort of like a backtrack to skills that we learned or hopefully solidified in 6th grade. But if you didn't, that's why I'm exactly making this video. So we will go ahead and get started with what we have for today. Now, if you notice, I have mentioned that this is the T called 6.3E. So if you wanted to open up Go Math and toggle to the 6th grade book, you may do so. Click on 6.3E in the table of contents, and it'll take you straight to more information about this particular TEK. Now, some of the things that we need to remember when we are multiplying and dividing fractions. First of all, multiplication okay. When we're dealing with multiplication, there is a common misconception from some students and adults alike that you have to find a common denominator when you are multiplying fractions. Now, I like to talk to my students about going to Walmart and going home. That's a conversation that we have about efficiency. Now, do we want to go to Walmart, which means that we need to take a right at the light, go down the street, turn, make another turn, get to the store, and then turn around and go home? Or do I just want to turn out of the parking lot and go into my neighborhood and quote unquote go home? Now, that is about efficiency. I do not have to find a common denominator when I'm dealing with fractions. I just have to multiply across. Also, with division, we need to remember that we are going to keep change, and your kids may be familiar with the acronym F, okay? KCF. Now, we're actually not going to use flip because that's not a very accurate math-related term. I want to use the proper vocabulary, so if in case they are confronted with the word reciprocal, which is what I want to change this last one to. So we're going to use KCR as opposed to KCF. That would be keep change, and to use the reciprocal or to reciprocate. But I will talk more about that in just a moment. Okay, so first things first, we're going to look at two different examples of multiplying fractions. The first of which is just going to be a simple fraction that you would be familiar with, 3/8 times 2 over 6. This means multiplication. That's just a shorthand for that. Now, in some cases, I will use the regular sign that you guys are probably familiar with. And then I'm going to use that dot in some cases. They can be used interchangeably. Now, remember, when you are multiplying fractions, you would simply multiply across. Okay, so 3 times 2, that's why I'm going to reformat that and rewrite that here. And then 8 times 6. Now, in this particular instance, what I want to do is I want to make sure that I do not come up with this monstrous fraction. I'm going to go ahead and multiply across. So right now I have 6 over 48. Now, if I'm trying to simplify that, what does that become? That becomes a conversation of my common factors between the top and the bottom, the numerator and the denominator. Or I'm going to rewrite this a different way. I want to see if there's anything that I can actually cross simplify. When I say cross simplify, I'm going from numerator to denominator diagonally. Are there common factors that these numbers would share? I know that 3 and 6 shares one common factor. Can you think of what that was? Okay, it's going to be 3. So 3 divided by 3 becomes 1. 6 divided by 3 becomes 2. I'm going to do the exact same thing for these two numbers. Greatest common factor between 2 and 8. You guessed it, 2. So I'm going to change 2 divided by 2 is actually going to become 1. Sorry, I miswrote that. 8 divided by 2 becomes 4, and I'm going to do the exact same thing. I'm going to multiply across now. This becomes 1 times 2, 1 times 2, 4 times 2 is 8. Now, 2 over 8. I'm so sorry. I misread that again. Please excuse me. Remember, this was 1. Sorry, I'm looking at one thing and writing the other, okay? So I'm going to correct myself. What does this prove to myself? This proves that you always need to be on the lookout for your own mistakes. You always need to be on the lookout also for what is reasonable. I knew in my head immediately, I was like, wait a second, 1 times 1 is not 2. I did something wrong. So I back up. Okay, remember that was a 1. Sorry, I wrote that wrong. I should have just erased it. Okay, 1 times 1 becomes 1. 4 times 2 becomes 8. So that leaves us with 1/8 as that particular answer. Now I'm going to look at multiplying a mixed number in what I call a regular fraction, okay, the standard fraction. What is the extra step that I need to do when I'm multiplying across, okay? In some cases, I may need to change a mixed number, I'm going to use the number sign, to an improper fraction. You guessed it, okay? Change that to an improper fraction. Now, what am I going to change this to? I know that when I'm converting to an improper fraction, I need to take the denominator here, multiply it by my whole number, 4 times 1, that's 4. Add that to what's in my numerator, that is 6, and then I'm going to use that as 6/4. I'm going to set this up again as a multiplication problem. I need to be thinking about what I can cross simplify. Greatest common factor between 6 and 12. I know that my factors of 6 are 1, 2, 3, and 6. I know that my factors of 12 are 1, 2, 3, 4, 6, and 12. So what was that greatest common factor? You guessed it, it was 6. 6 divided by 6 is 1. 12 divided by 6, 2. Same conversation that I'm going to have with myself. Greatest common factor between 4 and 6. Factors of 4 are 1, 2, and 4. Factors of 6, 1, 2, 3, and 6. Sounds like that the greatest was 2. 4 divided by 2, 2. 6 divided by 2, 3. Again, I'm going to multiply across. 1 times 3, 2 times 2. So this becomes 3/4 is my answer, okay? Now, moving right along to my division of these numbers. So I have 1/4 divided by 1/8. 1/4 divided into parts of 1/8, okay? So I know that, again, I'm going to keep, change, reciprocate. I'm going to rewrite these as 1/4. I'm keeping this first one. I'm changing my sign. And I am doing the reciprocal of 1/8, which is 8/1. Okay, so now I'm going to, again, see if I can cross simplify anything. Are there any common factors between 1 and 1 besides the number 1? No, so that is a no-go there. What about 4 and 8? Greatest common factor. Factors of 4, 1, 2, and 4. Factors of 8, 1, 2, 4, and 8. You guessed it, it is 4. 4 divided by 4, 1. 8 divided by 4, 2. So I'm going to multiply across 1 times 2. 1 times 1. Now, here is a conversation. When I multiply these across, I get the number 2/1. That is not the same as 1/2. 2/1, I can make any number into a fraction by simply putting it over 1. So this actually is going to equate to the number 2. So 1/4 divided into parts of 1/8. Okay, it's going to be 2. All right, next, I'm going to look at 2 2/9 divided by 10/18. So just like in this particular example, I need to turn this into an improper fraction, multiplying denominator times whole number. That's 2 times 9, 18. 18 plus 2 is 20. Put that back over the denominator. That's 20/9. I'm going to simply rewrite this. Now, you ask yourself, Mr. Moore, how come you just don't do KCR right then? The reason that I don't do KCR right then is because I want to make sure that I have everything that I need without trying to do 2 steps in one, because what happens when you are hurriedly trying to get things done? That's right, you make mistakes, okay? Now, let's go and see if I can change this size a little bit. Okay, make it a little bit bigger. All right, thank you. It's driving me a little nuts. All right, so next, greatest common factor between 9 and 10. 9 and 10, there are none, but guess what? I didn't do my keep, change, reciprocate yet, okay? So keep in mind, I did that because people will automatically try to start more than one step at a time, and you don't want to do that, okay? So 20 over 9, I'm going to change this to 18 over 10. Now I see that there are common factors. Greatest common factor between 20 and 10. You guessed it, 10. 10 divided by 10, 1. 20 divided by 10 is 2. Greatest common factors between 9 and 18. It's 9. 18 divided by 9, 2. 9 divided by 9, 1. Okay, so 2. And I think I'm going to write this down here because I don't want to not have enough room. Okay, so 2 times 2, 2 times 2, 1 times 1. And what I just say in the last problem, I'm going to go ahead and consolidate those. 2 times 2 is 4. 4 over 1. You guessed it, it's going to be 4. Okay, now let me move this up just a bit. Okay, so one more time. 2 times 2 over 1. 2 times 2 is 4. Back over 1. I keep going, giving myself a methodical, logical way of simplifying. Now, I've done 4 examples here for you, but if these 4 examples went by a little quickly, that's the reason that we have a video. You can rewind them as many times as you want, watch them as many times as you want. And if you have additional questions, you could always ask me in class. You may ask me at tutorials on Tuesdays and Thursdays. So, unless there are any further questions right now, and I don't see any hands, okay, you can always touch base with me in tutorials, like I said, or class. And if need be, just watch the video again. Since there are no questions, I will see you guys in class.